Hello everyone, welcome back to Emmanuel Tutorials. Today we'll be seeing a doubt asked by one of our students in the comment section. This is a sketch the signal example from a signal which is already given. So you have to also first find out the first x of t and derive y of t using the x of t that you have found out. If you also have any doubts related to signals and systems or any other concepts in electronics or telecommunication engineering, please put it in the comments and we'll try to respond. So let's start. Here, the signal is like you can say addition and subtraction of unit step signal variations. So first we have u of t. U of t is the unit step signal. So it is a signal, continuous time signal, which starts from 0, goes up to infinity with amplitude 1. Second part will be a delayed version by 1. Delay means you're going to shift it to the right by 1. So this is our second part of the signal, starting from 1 to infinity, amplitude 1. Third part of the signal is u of t minus 3. So u of t minus 3 is again a shifted to the right by 3. So it's going to start from 3 and go up to infinity. And 2u of t minus 3 will be the amplitude scale version of the signal. So it's from 3 to infinity, it is 1. So 1 multiplied by 2, which is 2. Amplitude will be 2. It will go up to infinity from 3 or t equal to 3. So in between, what I've done is I have added the first and the second part so that it becomes easier. So first and when we add first and second signal from 0 to 1, first signal's amplitude is 1, second signal's amplitude is 1 or is 0, and it goes up to 1 at 1. So from 0 to 1, our our resultant signal's amplitude is going to be 1. At 1 it rises up to 2, and from 1 to infinity both signals amplitude is 1. So 1 plus 1 will be 2. So our resultant signal's amplitude is also 2. So this is our addition of first and second part of the signal. Now this signal we will be using to subtract. So the third part of the signal will be subtracted from this signal. So third part of the signal, if you see, is this one. Now we'll consider this one as first, this as true. Now we have to subtract second from first. Now from the first signal, at 0 amplitude is 1, second signal 0 amplitude is 0. So 0 to 1, first signal's amplitude is 1. So that is what we have drawn here. This is our, you can say, x of t. From 1 to 2, first signal's amplitude is 2, second signal's amplitude is 0. So it will, in our resultant signal, we'll be putting amplitude as 2. You can even say that you can just replicate the original signal shape, because that signal plus 0 is going to be the same signal. So you can just replicate the shape until where the amplitude changes. So at 3 you can see first signal's amplitude is 2, second signal's amplitude is also 2, and 3 onwards till infinity the same behavior is seen. So first signal's amplitude is 2, second signal's amplitude is 2. So 2 minus 2 will be 0, continued till infinity. So at 3 our amplitude becomes 0. So that's what I have drawn here. So this is our final x of t. And for our y of t, what we need is time scaled versions. So one is x of 2t and one is x of minus 3t, and we are going to add both. So for x of 2t, it's going to be a time scale version by 2. So what will happen is the signal at 0 will appear at 0 by 2, which is 0. Signal at 1 will appear at 1 by 2, which is 0.5. Signal at 2 will appear at 2 by 2, which is 1. And signal at 3 will appear at 3 by 2, which is 1.5. So this will be our resultant time scale version of x of t, which is x of 2t. And for x of minus 3t, one point we'll be doing is scaling by 3, and then second one will be time reversal. So scaling by 3, what will happen is signal at 3 will appear at 3 by 3, which is 1. Signal at 0 will appear at 0 by 3, which is 0. Signal at 2 will appear at 2 by 3. Signal at 1 will appear at 1 by 3. And then when you reverse it, you will get a signal which looks like this. So this is our x of minus 3t. So I've drawn it directly. You can also try to find out the between steps and then draw this final one. And our y of t is the addition of both of these. So we'll be adding both. So from minus 1 to 0, first signal's amplitude is 0, second signal has a signal. So when we have a signal, when there are two signals with first signal's amplitude as 0 and second one has a shape, you can say that the same shape will get replicated when we are adding. So that is what I have done here. So here you can see clearly that at minus 1 it is 1, at minus 1 by 3 it goes down, and it comes to 0, it comes to 1 at 0. So the shape remains as it is. And for the second part, like addition, from 0 to infinity, second signal's amplitude is 0, and the first signal's amplitude is changing like this, or it has a particular shape. So you can just replicate it as it is. So here you can see it's a signal which starts from 0 and goes to 1.5, and I've just put the shape as it is. So you can say that this is 1, and this point is zero point 0.5, and this is 1. So this is our final signal. So it's a signal which starts from minus 1, ends to 1.5, and it has a amplitude drop in between. Hope you got this. If you have any doubts related to this question or any other concept, please let us know in the comments and we'll try to respond. And if you have computer science engineering related doubts, you can put it on the Ebenezer Tutorials channel on YouTube, and we'll try to respond. We also have some videos already related to data structures, which will be very useful. You can go through them. Please like, share, and subscribe to Ebenezer Tutorials and Emmanuel Tutorials for me. Thank you.